So in our last class, last time we got together, we talked about some congruence shortcuts, ways to prove triangles congruent. So our first one that we did from yesterday was side, side, side. And the second one we did yesterday was side, angle, side. The one that did not work, remember, was side, side, angle. And don't spell it backwards. So notice that the ones that we tried last class were involving mostly sides that were congruent. And we had one angle congruent. So today's we talk about angles being congruent and maybe a couple sides, and we'll see what happens. Again, we're going to go to jump to Geometry Sketchpad. The three that we're going to check out are what we call angle, side, angle. So notice that the side is between the two angles. So like last time we had an included angle, now we have an included side. The side is between the two angles. This is what angle, side, angle looks like. We're also going to talk about side, angle, angle. I'll also abbreviate this as AAS. When I was in high school, that's what we called it, so it kind of stuck with me that way. And again, notice that this one has the non-included side. So now you have your two angles congruent and a side that's not between them. And our third one is angle, angle, angle. And we'll see if that produces congruent triangles. So again, we're going to go to Geometry Sketchpad to check this out. So here's my angle, side, angle relationship. And what I want you to notice is that if I move point C around, that my other triangle moves similarly. So the angles are congruent. My side AB and side DE are congruent. And what I'm going to do is I'm going to extend these DFs and EF segments until I can get them to kind of be, they're pretty close on top of each other. Let me grab this, we'll slide it up here, and sure enough, it looks like those two triangles are congruent. Now, there's no other triangle that I can make using these two sides. So the only one that I can do has to be triangle DEF. So angle, side, angle. It's good. If we have an angle, side, angle relationship between two triangles, the triangles are congruent. The next one we're going to do is angle, angle, side. And we're really not going to do a lot with angle, angle, side, because if you think about this for a minute, do you remember if two angles of one triangle, like angle A and angle A and angle B, are congruent to two angles of another triangle, angles D and E? So angle A is congruent to angle D, angle B is congruent to angle E. What must be true about angles C and F? Yeah, they got to be congruent. So if angle C is congruent to angle F, then by angle, side, angle, my triangles are congruent. So we actually prove angle, angle, side works by using angle, side, angle. Pretty neat. So angle, angle, side, good. And finally, let's take a look at our last one. Our last one is angle, angle, angle. And sure enough, it looks like those two triangles are congruent. But wait a minute. If I drag on to, say, like vertex E, I forgot which vertex I want to drag, I can make the triangle bigger or I can make the triangle smaller. And notice when I grab it, I still have those angles congruent. I still have angles C and F congruent, and A and D are congruent. So I've got three different pairs of angles congruent, but the triangles are not congruent. So therefore, angle, 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 no good. So that brings us back. We'll go all the way to the beginning for a moment. Let's add into our congruence shortcuts angle, side, angle, and angle, angle, side. And the two that don't work, side, side angle, and angle, angle, angle. And that's what it's all about for triangle shortcuts.